pigeonhole principle. So it really does get its name from birds. So I'm going to try and draw birds. So if I've got 3 birds and they're running for shelter because it's starting to hail, then, and there's only 2 holes for them to go into. So one of the holes is going to be crammed with 2 pigeons because there are not enough holes for the pigeons. So when the domain is larger than the codomain, right? So the codomain, right? Then for sure you're going to have 2 birds in one hole. That's the main idea. So you can think of the birds and the holes. Okay, so here we go. So here we have 6 people. So this domain would be the 6 people. And the question is, will there be at least 2 of them or were born in the same month? And so then the codomain would be the 12 months. Oh, this number is not larger than this number. So I can so the answer would be no, because you could have all 6 people have their birthdays from January to June, and there's no overlap. All right, so here we have 20 socks. And what do I have? I've got 2 colors, kind of like 2 holes, right? So what's the least number of socks you have to pull out to make sure you get a matched pair? Well, if you pick 2, it could be a black and a white, right? Worst case scenario. But once you go pick the 3rd one, then for sure you've got a pair of white or a pair of black. Okay, so here we have, they want us to, they're going to pick 5 integers. Does at least one of the pair have a sum of 9? So let's list the possible pairs that give me a sum of 9. So out of these numbers, the possible pairs could be 1 and 8, 2 and 6. I'm sorry, 3 and 6, 2 and 7, and 4 and 5, right? So those are the possible pairs that gives me a sum of 9. And so how many are we going? So there's 1, 2, 3, 4 of them, 4 pairs. And if I go and choose 5 of them, 5 numbers. So worst case scenario, right? You want to think that, to go pick these 5 numbers, are we going to get a pair? Yes, because there's more when I pick 5 numbers. So pick 5 numbers. So that's the domain. And the number of pairs that I've got are only 4. And so 2 of the numbers will be in the same hole. So 2 of the numbers will be making a sum of 5. So yes, more in the domain than in the codomain. So what if, just kind of taking this just same question, we only pick 4 integers? So no, because if only pick 4, so pick 4 numbers and there's 4 pairs, then there's this domain number is not larger than the codomain. So the answer is no. All right, so now we're going to generalize the pigeonhole principle so that we can answer kind of different questions. So we're going to use this like n for number in x and n for number in y. So we've got a set x going to a set y, and they're finite, so we're not talking infinite things here. We need to have that. We will find out that the number in x is bigger than k times the number of y. So, and that means there has to be k plus 1 distinct elements in the x. So, or k plus 1 pigeons, right? In order to get an overlap. So let's use this. We're talking about 85 people. Do 4 of them have the same last initial? So the number in the domain is 85. So that's the n of x, right? And the number in the codomain is 26. So this is the n and the m here, right? N is number in a domain. M is the number in the codomain. And so we're going to use this little nifty formula that says the number in the domain is bigger than some number times the 26. So I know that 3 times 26 is 78. So that means that keeps the 85 larger than the 78. So that means k is 3. And so to answer the question, there's going to be k plus 1 or 4 people that have the same last initial. So that's one way to do it. So play it with like this. Or we could just take the ceiling of n over m. So if we take 85 over 26, that gives us a little more than 3.26, and we know the ceiling of that is 4. So that means there has to be 4 people. So it's going to be necessary for you to use know both of these because they come up in different ways. All right, so let's look for the number in the domain. So that would be the n. So a group of 40 people. And the number in the codomain, what are we doing here? Born in the same month. So the M would be 12. So domain and codomain. So let's use the ceiling. So if I take the 40 divided by the 12, that gives me a 3.33. And so the ceiling of that would be 4. So yes, 4 people have the same birthday. Same birthday month, right? B-day month. Okay, so let's do it the other way where I'm trying to get the blue here. Or I could say the number 40 has to be bigger than k times the 12. And so I can see that k's got to be 3, right? So that keeps 36 less than 40. And so k plus 1, or 4 people had the same birthday month. So you get the same answer just in different ways. Okay, use the pigeonhole principle to show that if 7 colors are used to paint 50 bikes, that at least 8 of them will have the same color. So the domain would be n of the 50 bikes, and the codomain is the 7 different colors. So let's do the ceiling. So if I take 50 over 7, I know that that's 7 and a bit, right? 7, and I know that that ceiling then will be 8. So yes, there will be 8 bikes the same color. Okay, so then let's do it the other way. So I would want to say 50 is larger than some number k times 7. So yeah, k is 7, right? That gives us 49. So that means k plus 1, or 8 bikes of the same color, right? Same color. So just know how to work both ways because there's going to be different situations where you'll need one or the other. Okay, so here, I guess I just did this one for you. And I'll just let you read that. Oh, wait a second. We want to find how many friends. Oh, we want to find n. Oh, this is different. So we know n over 12 has got to be 5, right? Because we want 5 of the same color. So, or 5 of the same birthdays. So if k plus 1 is 5, that means k is 4. And so now using this, n has got to be bigger than 48. So that must mean n has to be 49.